Welcome to the DIY Honda Garage channel. The DTC P0120-17 and P0123 codes indicate an abnormal condition with the throttle position TP sensor A circuit, specifically that the sensor output voltage is higher than the allowable range. The TP sensor is vital for monitoring the throttle valve's position and thus governs air intake and engine performance. In a 2023 Plus Honda CR-V, the TP sensor is integrated with the throttle body assembly, located in the intake manifold just downstream of the air filter. The Powertrain Control Module, PCM, utilizes TP sensor data to adjust fuel mixture and ignition timing accordingly, ensuring efficient engine operation. When the PCM detects unexpected high voltage from the TP sensor, it registers these DTCs for troubleshooting. Understanding the context and causes of these DTCs is essential for efficient diagnostics and repair. The first step in resolving these DTCs is a systematic examination of related components and their electrical circuits to accurately pinpoint the problem. The Throttle Position Sensor, or TP sensor, is an integral component in managing the vehicle's air intake. It relays critical information regarding the position of the throttle valve to the Powertrain Control Module, which is often referred to as the PCM. In the Honda CR-V 2023 Plus, the TP sensor is physically integrated into the throttle body assembly, situated on the intake manifold. This positioning allows it to directly monitor the throttle's operational status. The PCM uses this data to make real-time adjustments to fuel delivery and ignition timing, enhancing engine performance, fuel efficiency, and emissions control. When the output voltage from the TP sensor is detected as excessively high, it indicates a circuit issue, leading to the triggering of DTC P0120-17 or P0123. Understanding this circuitry and its components is crucial for effective troubleshooting. Identifying the possible causes of DTC P0120-17 and P0123 is critical in the diagnostics process. A faulty throttle body can disrupt the TP sensor's functionality, leading to inaccurate readings. Problems can range from wear and tear to complete sensor failure within the throttle assembly. Additionally, wiring or connector issues, such as damaged wires or poor connections in the circuit between the TP sensor and the PCM, can cause erroneous signals to be sent. Such breaks or failures in the electrical system result in communication breakdowns, leading the PCM to see high voltage signals where none should exist. Finally, a malfunctioning PCM itself can also result in these DTCs, though it's typically the last component evaluated after others have been ruled out. When the DTCs P0120-17 and P0123 are triggered, various symptoms may manifest, significantly affecting vehicle operability. One prominent symptom is poor engine performance, which can include sluggish acceleration, hesitation, or stalling while driving. This occurs as the PCM misinterprets the signals from the TP sensor, leading to improper fuel mixture or timing adjustments. Another common symptom is illumination of the check engine light, which serves as an alert for the driver to address the issue. Additionally, the throttle may also become unresponsive or feel locked, preventing adequate power delivery and making the vehicle difficult to drive safely. Recognizing these symptoms promptly can assist in efficient troubleshooting and repair. The first step in troubleshooting DTC P0120-17 involves turning the vehicle into the on mode. This action ensures that all necessary electrical systems are activated for diagnostic purposes. Once in this mode, it's essential to monitor the TP sensor A value using a diagnostic scan tool such as the HDS Honda Diagnostic System. This tool will display the actual voltage output from the sensor. If the HDS indicates that the TP sensor A voltage exceeds 4.8 volts, this confirms that the failure condition is duplicated, validating the DTC. The results from this preliminary check help in determining whether the issue is isolated to the throttle body or involves other components, guiding the next steps in diagnosis effectively. For the second troubleshooting step, begin by disconnecting the throttle body connector, which is a 6-pin 6P connector. This disconnection is critical for isolating the throttle body from the circuit during testing. Next, use a jumper wire to connect terminals number 6 and number 3 of the throttle body connector. This step simulates a condition where the TP sensor should have an output voltage reading. After establishing this connection, turn the vehicle to the on mode once again. At this point, the HDS tool should display a TP sensor A value that reads approximately 0 volts when everything is functioning correctly. If the reading is normal, it indicates that the throttle body might have an internal failure. However, if the reading is abnormal, the potential issue lies in other related components or connections. The third step in the troubleshooting process involves conducting a thorough inspection of the external circuit associated with the throttle position sensor. Before carrying out this inspection, it's crucial to ensure the throttle body and PCM connectors are disconnected to avoid any electrical shorts or confusion. Check the VCC3 power supply, THL1 signal, and SG3 ground circuits specifically. These connections are paramount in ensuring proper communication between the sensor and the PCM. Using the HDS tool, perform an inspection to identify if there are open or shorted wires by examining resistance levels. The expected results should confirm a specific resistance range for normal operation, with values of less than 1 ohm being typical for open wire tests and more than 1 mega ohm for any shorts. Document any abnormal results to aid in further diagnosis. The fourth, and often final, troubleshooting step is to inspect the powertrain control module, or PCM, itself, if all previous checks returned normal results. This inspection includes examining the PCM for any internal faults or failures. If other inspection items confirm normal conditions without electrical faults, then it's prudent to suspect the PCM as the root cause of the DTCs. Various diagnostic tests can evaluate the PCM's integrity, ensuring its logic and processing functions are intact. If faults are detected during this PCM evaluation, a replacement may be necessary. The PCM plays a critical role as it processes signals and modulates engine management functions. Thus, ensuring its operational status is vital for vehicle functionality. After completing the necessary repairs and confirming the integrity of circuits and components related to DTC P0120-17 and P0123, it is crucial to conduct a final repair verification. Begin by using the HDS tool to clear all stored DTCs from the system. This step will provide a clean slate to monitor for any reoccurring issues. Following this, perform a thorough road test of the vehicle to ensure that it responds properly and operates without triggering any DTCs. During this test, pay close attention to the throttle response and overall engine performance, verifying that everything is functioning within normal parameters. If no DTCs reappear and the vehicle operates smoothly, you can confidently conclude that the repairs were successful. Preventive maintenance is essential to avoid issues like DTC P0120-17 and P0123 in the future. Regular inspections of wiring and connectors associated with the throttle position sensor and throttle body should become routine practice. Over time, wear, and environmental factors can lead to degraded connections, which might result in electrical problems. A visual inspection allows technicians to catch and rectify these issues early. Additionally, performing routine cleanings of the throttle body can prevent the buildup of carbon deposits and other obstructions which might impair the sensor's operation. By incorporating these preventive measures, vehicle reliability and performance can be significantly enhanced. In conclusion, understanding the implications of DTC P0120-17 and P0123 is vital for those diagnosing and repairing Honda vehicles. Following a structured troubleshooting approach allows for accurate identification of the root cause, whether it's related to the throttle body, wiring, or PCM. Each step is essential, as overlooking a minor detail can delay the repair process and lead to further complications. Additionally, implementing preventive maintenance practices can prolong the lifespan of critical components and ensure optimal vehicle performance. Awareness and diligence in handling these DTCs will ultimately lead to more efficient repairs and a better driving experience for CRV owners. Please like and subscribe to the channel. See you next time!